So, hi dear masters, this is lesson 12, testing 2 reports, second part of testing, and devoted for the first course master students. Main source is the same, David Bonami's Technical English course book, upper intermediate level, page 76-77, or you can download the book and work on it with full format of audio script in order not to be plagiarized version. So let's talk about the testing report. First of all, we need to discuss these two figures. Why might the wall in figure 2 resist an earthquake better than the one in figure 1? We need to compare these two figures, figure 1 and figure 2. Normal wall and seismic composite wall. Why this one is more resistant to earthquake? Let's analyze every element of this figure. First one, load-bearing concrete columns are given here on this version, but here load-bearing seismic wall were given on another version. So difference of the walls are different here. Here columns are given with 6 parts, but here is complete form are installed. Second difference is partition wall in the center of that wall, and here lightweight partition wall also in the center, but from the side. Here it is in the center. Second difference. Third one, non-load bearing infill wall here, but they're full slab. So you can see and note there is no infill wall. You could understood, right? It is complete form of installed wall are more resistant than the tapered columns. This is the difference of these two figures. So, reading part of the lesson, give each section A to H of this report of heading from the box, then put section in the best order. So we need to use this box word in the spaces, like first A passage. The walls were subjected to push-over test. First, they were placed side by side and attached to a rigid metal base. They were then pushed sideways in opposite direction by 200-ton jacks. This test simulated the lateral forces acting on shear walls during an earthquake. After the test, the walls were visually inspected. So which part of this box word we can put here? You will think yourself. It's like second B passage. The test was prepared by fabricating two large 2.8 by 3 meter walls using this composite seismic wall system. One wall was reinforced and the other was unreinforced. Several motion sensors were then attached to the wall, the base to measure wall displacement. In addition, a computer model of the effect of the cold earthquake on a 7-story building was produced so that the correct force could be applied to the samples. The same on this book we need to put. Next one, introduction given. If load-bearing walls can remain standing after severe earthquake deaths, property damage can be minimized. To meet this need, a composite seismic wall has been designed, consisting of polymer outer skin filled with a concrete. The result is a ductile, non-brittle polymer concrete composite, which is designed not to collapse even if the concrete inside is fractured. As a request of the designers, we were engaged to test the composite seismic wall system for use in earthquake zones. This document is a report of the test which was carried out in April this year. So, answer introduction given as a second. Only thing we need to put the order. It comes first one. You need to write here what. D part. The maximum capacity of the reinforced wall will be determined by the future test on the shake table, where it will be subjected to magnitudes up to 8. Table 1 extract results of computer modeling. In the table you can see the figures. And last part, it can be concluded that the unreinforced wall can resist 7.3 magnitude earthquake without significant damage. Order and title. The purpose of the test was to confirm the adequacy of the composite seismic wall system in resisting sideways force during earthquakes of up to magnitude 7.3, called 1994. And last one, table 1 in the appendix indicate that the maximum interstory drift demand In a 7-story building, the core earthquake, as shown in our computer model, was 5.8 millimeters and occurred in the 5th story. Following the test, no signs of damage were observed. Only we need to fill the gaps by altering them. Then, discuss sink part. What causes this bridge to sway? It is a sample of this bridge, the London Millennium Footbridge. Practice your speed reading. First thing, look for the information you need on the speed survey page 167. In full form, you can find out this book. Try to be first to complete the information about the bridge. Only thing is you need to complete these places again. Then home task writing. So at home you need to pay attention and write this report for the graph. This graph shows the result of one of the tests carried out later on the bridge. Discuss this question. What can you deduce about 1, the procedure, 2, the objective, 3, main result of the test. So you need to write 3 main features in this task writing. Pay attention to these numbers and these numbers left to right side, magnitude of earthquake. Then last, use your notes to help you write a report on the test carried out on the bridge. Make your report as concise as possible. Thank you for attention.